In this A-level further maths video, we're going to look at integrating partial fractions actually. So in order to integrate this whole function, we want to split it up into partial fractions. Now when you split up into partial fractions, you're going to write ax plus b. So it's important that you write ax plus b over 2x squared plus 3 because, well, the highest power in the denominator is a power of 2. So we need to put a power of 1 in order to just account for anything that could come as an x term. And you can then add onto that a c over x plus 1. A, B, and C are just random rational numbers that we're yet to find, but we need to find to do the whole of this question. So if we now think about it, to make this first fraction match this denominator, we need to multiply the bottom by x plus 1. So you're also going to multiply the top by x plus 1. So we're going to write ax plus b, lots of x plus 1. In a similar way, in the second fraction, to make it match the denominator of this fraction, this denominator here, by the way, to make this denominator match, you need to multiply 2x squared plus 3 to the denominator. So once again, you're going to do that to the numerator. So see lots of 2x squared plus 3. So all over that common denominator now of 2x squared plus 3 multiplied by x plus 1 is all going to be equal to the function that's given in the question. Instead of writing this whole thing out, it's easy to see that the denominators match, so the numerators have to also match. So we can make the numerators match, and we can say that ax plus b, lots of x plus 1, plus c, lots of 2x squared plus 3, is all equal to the numerator on this function here, which is 8x minus 12. Now, in order to solve this, let's have a little think. It might help to make x equals minus 1, because what that will do is make this whole first bracket, or the whole combination of these two brackets, equal 0, because minus 1 plus 1 is 0. But this second sort of term here, well, minus 1 all squared is positive 1, times 2 is 2, plus 3 is 5, so we have 5c is equal to 8 times minus 1 is minus 8 minus 12 is minus 20. We can then divide both sides by 5 to get that c is equal to minus 4. Not only have we found c, but we now need to work on finding a and b. Now, in order to find that, what I'd recommend you do is, well, let's compare coefficients actually. If we compare coefficients of x squared, well, expanding this out, this will become ax squared. If we look at this term, we can get a 2cx squared here, and we can extract that, that's equal to 0x squared on the right hand side. So comparing the coefficients of x squared, we can say that a plus 2c is all equal to 0. Because we know that 2c is already equal to, we know c is equal to minus 4, we can say a minus 8, because 2 times minus 4 is minus 8, is equal to 0, which only occurs when a itself is equal to 8. Now that we've got a and c, we can now find the value of b. Instead of comparing coefficients of x squared, let's compare the constants now. So ax times x won't give you a constant, ax times 1 won't give you a constant, bx times 1 won't give you a constant, but b times 1 will give you a constant of b. If we add on to that the constant that we get from expanding this out, so c times 3 is 3c, we can now make that equal to the constant on the right side of the equation, which happens to be minus 12. Once again, we can use the c value that we found before of minus 4. 3 times minus 4 is minus 12. So if b minus 12 is equal to minus 12, then it's pretty clear that b is just going to be equal to 0. Now that we've got values of a, b, and c, we can put them into this function. We have ax, which is 8x, all over 4x squared plus 3, plus c, which is minus 4. So it's best to just replace this with a minus and then put the c value as 4, all over x plus 1. Now, there is a rule in A-level maths that when the... well, let me write this out better. But when you have a function where the numerator is a differential of the denominator, then that always integrates to ln of the denominator. In this case, we know 4x squared differentiates to 8x, so we can just say that when you integrate this, because remember, we are integrating this whole function here, which happens to be the same as integrating each of these individual fractions, this will just integrate to ln of 4x squared plus 3. Take away, and then differentiating x plus 1 will differentiate to 1, but we have 4 times that, so we can write 4 times ln of x plus 1. Now, when dealing with this, because it is logarithms, we can take the number before the logarithm and we can make it a power. And also, because we're subtracting logarithms, we can divide the insides of the logarithms. So we can write this out as ln of, and then in a big bracket, 4x squared plus 3 all over x plus 1 all to the power of 4, which I'm just going to very quickly write out. And then it has given us limits here, hasn't it? It's given us limits of infinity to 0. So let's have a little think about this. What that means is, I'm going to just put big brackets around it. Well, let's see what happens to each of these terms. if we have a very large number, okay, I'll show you a little trick with this actually. Although we are finding the value of essentially when x is infinite, honestly just put a very large value of x into it and see what happens to the whole function. So let's do that. When you put let's say x equals 9999, so we have a ln of, let's put 5 nines, 1 2 3 4 5. This will allow us to see the relationship and what happens as x gets very, very large. 99999 plus 1 all to the power of 4. Okay, so what I've spotted here is that, okay, what if you go further? So, okay, it will just continue getting smaller and smaller. How about we approach this in a different way then? What if we... Sorry, I'm just focusing on one little thing here. Okay. What if we... infinity squared of infinity to the power of 4. If we first put 0 into this, let's see what happens there. So ln of 0 plus 3 is 3, all divided by 0 plus 1 is 1, all to the power of 4. So 1 to the power of 4 is just 1. So that will become ln of 3. So we subtract from whatever we get from ln of 3. We now need to think about what happens as x gets a very, very large number. Well, let me try an even larger number actually. So 4 times 999. Oh, again, I'm going to try 5 nines, all squared plus 3, all divided by 1 2 3 4 5 plus 1 all to the power of 4. What I see when I put infinity into this function is that the inside of this function gets closer and closer to 0. Now, ln of 0, it actually doesn't exist. But because it doesn't ever reach 0, it's actually going to be, well, if we think about the ln graph, the closer it gets to x equaling 0, the more and more negative it gets, doesn't it? So essentially, this is going to be a very, very large negative value. So minus a very large negative value, take away the ln of 3. Now it says to put this in the form ln of k. So what you have to do is... Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excellineducation.co.uk.